Hi everyone, welcome to the demonstration of estimating the ARC model. Now remember I said we can only use the ARC model if we are certain that there is a presence of volatility, or if we are certain that there is a presence of the ARC effect. ARC effect is the same as presence of volatility. So now how do we do that? The first thing that we have to do is to test for the presence of the ARC effect, or to test the presence for volatility, because if there's no volatility, then there's no need of using the ARC model, but rather then you have to use the usual OLS or other techniques. So how do we do that? First of all, we need to estimate an equation using the OLS. So here I'm going to use the exchange rate between the Namibian dollar and the US dollar. So, and it's for the period from 1993 to 2011, and I'm using monthly data. So now how do we do that? So first of all, you just estimate your OLS equation. So where you estimate, so you go to quick estimate equation, then you type USD. Okay, here take note that I just named the variable USD for easy use, but of course here this is the exchange rate between the Namibian dollar and the US dollar. So okay, so USD space C, USD lagged by 1 period. Okay, so that's what we are dealing with. All right, fine. So once we do that, we basically click on OK. Now, from this output, in order for us to test for the presence of the ARC effect, so we click on View, choose Residual Diagnostics, then we choose Heteroscedasticity. Now, when that box comes, we have to look at what test we have. Are we using here? We are using the ARC test because we want to test for the ARC effect, or the presence of the ARC effect. So we choose ARC, then we click on OK. So then once we click on OK, it will give us the table output. So all we have to do here is look at the probability values. So we can actually see that this probability value is actually less than 0.05. Now, what does that mean? That means that we have to reject the null hypothesis. What is the null hypothesis? The null hypothesis is that there is no ARC effect, while the alternative hypothesis is that there is an ARC effect. So now, based on the p-value for both the F statistics and the chi-square statistics, we can actually see that these p-values are less than 0.05. So meaning we are rejecting the null hypothesis, and so therefore there is a presence of the ARC effect, so meaning there is volatility clustering. So now that we know that there is the presence of ARC effect, so it actually means that we can go ahead and estimate the ARC model. Now, how do we do that? While we are on that, so we can basically just click on estimate, and while we are on estimate, we will then just come here to change the method of estimation. So, and what do? We basically click there, then we can see here we have ARC, autoregressive conditional heteroscedasticity. Okay, so we choose that. So now what you have to do is from here, so now you see here, this is the equation. You don't have to change anything. The only thing that you have to change here is you have to change this GAC to be 0. So meaning we are only here, meaning that you're only estimating the ARC model. So meaning GAC is 0 and then threshold is 0. We will actually get to use this one later when we talk about the GAC. So then we simply click on OK. Now, if we click on OK, so this is our equation. Now you can basically see that from this equation, we have the upper part, you have the mean equation. And then the lower part, we have the variance equation. So what we are interested in here is this coefficient. Now remember that equation that I showed in the lecture. Remember I showed you two equations. The mean equation where we say y is a function of the error term, right, from the past. And then we have the variance equation where we had sigma is a function of the mu squared t minus 1. So basically what we have there is now this variance equation is basically telling us that sigma is a function of this. This is your mu squared. That's why it's written as residual squared. So this is your mu squared t minus 1. So this is the coefficient. So now, in order for us to determine whether or not, in order for us to determine whether the volatility is persistent or not, what we do is we look at this coefficient. So if this coefficient is closer to 1, then it basically tells us that the volatility is very persistent. If it's maybe say closer to 0, then it basically tells us that the persistence of volatility or the clustering of volatility is very very minimal, or is non-existent. If it's equal to 0, it's non-existent. So that is basically how you estimate the arc model. Okay, that's how you estimate the arc model. So this is your mean equation, this is the variance equation. So, and that equation 8.11, and this is equation 8.12. Okay, and or with the final equation that we I think I said is 8.14 and 8.15. We had now when we changed to letter H, but they in actual fact as I said, those two pair of equations are just the same. What we did, we just changed the letter so that it's easier and we don't confuse it. So, but what you should know is that the first one is the mean equation and the second one is the variance equation. So if this coefficient, like now this coefficient is 0.57, which is about 58%, yes, we can say it's not necessarily high if in relative terms, but of course it is high. And so basically telling us that there is some level of volatility. Of course, if it was 0.8 or 0.9, we would then say it's highly persistent. Here we can basically say it is still persistent, but no, not necessarily too high, but it is still persistent because 58% is still a lot. Okay, all right. So that's basically how you estimate the arc model.